Hi, my name is Taylor Richardson, and I will be explaining my exam for the written exam, Module 2, Chapters 2 and 3 for Math for Teachers. Starting with number 1, the question was about create a three-loop Venn diagram and to show the 8 elements of U and then list the elements in the following sets. And so as you can see, I created my Venn diagram, and for A through G, I saw that for part A, we did all elements in circles B and C. So as you can see, that is G, D, H, and F. And I used the same method for the ones with the right side up U. And then for the upside down U, like parts B and C, that's what those elements had in common. So like for part B, I found what was in common between circles A and B and found that that was D and H and used the same method throughout. And like for part E, the A with the line over it meant that it was looking for all the elements except for part A, or what was included in circle A. So that was the only element that was not included in A was the letter F. And moving on to number 2, about the 12 shapes in the Venn diagram. I put the chart at the top to show what each letter meant. And then for part A, I found that L upside down UH, or union, H meant it included all the shapes that were large and hexagonal, the only large hexagonals. And for part B, it meant all circles and hexagons. And for part C, it meant all triangles that were not red. And for part D, it meant only circles that were small and red. And then for number 3, I wrote out all the different numerals for each different number system, for the Mayan numerals and Roman and Egyptian and Babylonian, and used these charts to be able to figure out the numbers that were listed in parts A through D. And so for part A, I found 30,054, part B, 2,137, C, 41, and D, 31. And then for number 4, I used the lattice algorithm for parts A through D and found the different answers to the equations. And for part A, I found 896. Part B, 171,444. Part C, 571,652. And for part D, I found 1,203,336 using this lattice algorithm. And for number 5, we used rounding to find the estimated answer for each problem, and then we found the exact answer. So for number 1, I found that it was estimated to be around 14, and then when I did the actual problem, I found that the answer was 10.6. And so the 14 was a little higher because, like for 800, we rounded that up to 900, and the 400, we rounded that up to 500. So rounding those numbers up really affected that end number going up a little bit, and it played the same for parts B and C. For part B, I found it estimated to be 70, but the actual answer was only 42.7. And again, this is because we rounded 5 up to 10 and 254 up to 300. And when you multiply 10 times 300, that equals 3,000. Whereas when you multiply 5 times 254, that only equals 1,270. And so that played a big part in finding the actual answer compared to the estimated answer. And then for part 6, we used the base 5 and base 6 algorithms. And for part A, I found that if you separate the equation into 3 columns, you can find that 2 plus 3 equals 5. And so that goes into 5 one time. So you can put 0 under there and move the 1 above the 3, showing that's the 5. And then use this same method. 3 plus 3 is 6, plus that 1 is 7. And so 5 goes into 7 one time, leaving 2. And then you move that 1 over for the 5 again and follow this through. And I found that the answer was 1,120 in base 5 algorithm. And that followed through with the rest of B, C, and D. So I hope that this was helpful and that you're doing good. Okay, thanks.